Today we are going to focus on Miller indices. Actually, Miller indices means it is a standard notation that can be used in crystallography. So actually what is crystallography means, you know, there are a lot of crystals we can find. It can be cubic one or rhombohedral one. Sometimes it can be a tetragonal one. But today we are going to focus mainly on cubic systems. So in different kind of crystals there can be different planes. In that planes we need to see how the atoms are arranged and what is the orientation of those atoms. So in that case, when we are going to know the direction, we need these Miller indices. Actually, Miller indices are designated by H, K and L terms. So each planes can be designated by H, K and L. The Miller indices are defined as reciprocal of the fractional intercept. So what is fractional intercept? Fractional intercept. Actually, fractional intercept means intercept length over axial length. Intercept length over axial length. For a given cubic crystal, the structure of those cubic crystals are like this. You can write like this. And those axial lengths are oriented like this. So this is your y-axis and this is your z-axis and this is your x-axis. In Miller indices, always these x, y and z axes are correlate with A, B and C. Here x-axis correlate with A, y-axis correlate with B and z-axis correlate with C. So for a given plane, if you have the Miller indices H, K and L, your fractional intercept means fractional intercept 1 over H, 1 over K and 1 over L, because Miller indices are defined as the reciprocal of the fractional intercept. So here your Miller indices and this is your fractional intercept. So if the axial lengths are A, B and C, these axial lengths are A, B and C, then your intercept length will be A over H, B over K and C over L. So this is how the arrangements are going to appear, and if you are given such a Miller indices, from that you can find out what is the fractional intercept and also the intercept length by using A, B and C terms. So you can clarify these things very much when I am doing some working problems with you. So let's move on to those problems. Here you have given a question, a particular plane cut x-axis at 5a, y-axis at 3b and z-axis at c. So we need to find the Miller indices of that plane. So in this case, we can work with the small procedure to find out the Miller indices. So we know in a cubic crystal, the planes, the axes x, y, z always correlate with A, B and C. So you can write the axial lengths A, B and C. So these are coordinate with X, Y and Z. Then here you have given the intercept length 5A, 3B and C. So intercept lengths you can write 5A, 3B and C. Now you can find out what is the fractional intercept. So fractional intercept, I already explained you earlier. Fractional intercept means intercept length divided by axial length. So fractional intercept is 5A over A, and this is 3B over B, and this is C over C. So what are the Miller indices? How to define Miller indices? It is the reciprocal of the fractional intercept. So now we can directly go to reciprocal. So reciprocal is A over 5A, B over 3B and C over C. So your value is 1 over 5, 1 over 3 and 1. Actually, from the reciprocal directly you can get the Miller indices. So now we can simplify this answer to get Miller indices, like 15 divided by 5, it is 3, then this is 5 and then this is 15. So these are your Miller indices, 3, 5 and 15. So in this case we can draw the plane also, this given particular plane. So let's see how to draw that plane. So this is the cubic system, the unit cell. Here they have given X, it will cut x-axis at 5A. So x-axis means this one. This is having the length A. So you need to count the length 5A. Sometimes it may be here. This is 5A. Up to here the length is A, and to here it will be 5A. Then in y-axis at 3B. So this is your y-axis and you can find where your 3B, and this length is B. Up to here the length will be B. So it will be 3B will be here, and set axis at C. So this is your length C. This small length will be C. So it will cut at C. So these dots will cover your plane. So the plane will be like this. The plane will be like this. So this is the plane having Miller indices 3, 5 and 15. So likewise, for any kind of given plane, you can find out the Miller indices, and also you can draw the plane also. This is your second question. Here they have given you a particular plane cut x-axis at 2A, y-axis at 5B and z-axis will be parallel. So you need to find the Miller indices of the plane. So here also you can use the same principle we used earlier in the first example. So your axial lengths will be A, B and C, and your intercept your intercept lengths are given here 2a, 5b, and this is parallel. That means it is infinity. Here it is parallel means the axis, the intercept length is infinity. Then you can find fractional intercept. Fractional intercept. Fractional intercept means intercept length divided by axial length. So that is 2a over a, 5b over b, and infinity over c. Then directly we can go to reciprocal. Reciprocal. So your reciprocal is a over 2a, b over 5b, and c over infinity. So this is your reciprocal, and from that you can get the value 1 over 2, 1 over 5, and this is, it is 0. So from these values you can simplify into Miller indices. Miller indices. So from 2 and 5 you can get 10. So 10 divided by 2 it is 5, and this is 2, and this is 0. So these are the Miller indices of that given plane. It is 5, 2 and 0. So now let's see how to draw that. You can write the cubic crystal like this. Here x-axis at 2a. So this is 1a, and up to here 2a. And y-axis at 5b. So this is b. Sometimes it will be like this. I will write here, it is 5b. And it will parallel to z-axis. So the plane is always parallel to z-axis. Now if we think about this point, here also this is x direction, it will go up to here. This is also 2a. And this is the y direction. From this direction we can write this is also 5b. So this is your plane going parallel to z-axis. This is your plane going parallel to z-axis. So this is the one we have drawn earlier, that Miller indices 5, 2 and 0. So this is the cubic system. If we go for a tetragonal system, the only difference is the shape of the system will be different, because this is made up of squares and tetragonal system made up of rectangles. That is the only difference. So let's see one example for a tetragonal cubic. Another question based on tetragonal lattice. In this tetragonal lattice, here they have given the c equals 3a, and other two lengths are same, and the particular plane cut x-axis at 5a, y-axis at 4a, and z-axis at 2a. So only the difference is here the crystal made up of rectangles. So this, if I take this length as c, this has 3a and this has the length a. So likewise we can think. Now we can use the same procedure which we have used earlier to find out the Miller indices. So your axial lengths will be A, B and C, and your intercept lengths will be 5A, And you know here B also equals to A, because for a tetragonal lattice only one direction is going to be different and other two directions are same. So this is for B, and Z axis is 2A. From this we can think, we know C equals 3A, and here A equals C over 3. So 2A means from A you can substitute C over 3. Then you can find out the fractional intercepts. Fractional intercepts. It is 5A over A, 4B over B, and here 2C over 3 over 2C over 3 over C. Likewise you can write. Then you can take the reciprocal, A over 5A, B over 4B, then 3C over 2C. From that you can get the value here 1 over 5, here 1 over 4, it is 3 over 2. So now you can simplify this into Miller indices. 5, 4, 2. So the value will be 20. 20 divided by 5, it is 4. Here it is 5, and here it is 10 into 3 means 30. So your Miller indices 4, 5 and 30. Your Miller indices will be 4, 5 and 30. And let's look at how this plane is. This is the tetragonal lattice we can draw. Here the only thing is these two lengths, the length B and length A are same, and only the length C is going to be different. Here the C is 3 times of A. Here the C is 3 times of A. So that is the only difference. So here it will cut x-axis at 5A. Sometimes will be here, but not actuality, because A is like this, then 5A will be a very big length. Then your y-axis at 4A. So this is the length B or A, because A and B are equal. So this is B, and it is 4A means 4B. That is another big length. I will number here. It is 4B. And this is z-axis at 2A. And from this you know C equals 3A, and 2A means it will be like here 2 over 3C. So your plane will be like this. So this is the plane we have drawn earlier. So likewise, when the intercept lengths are given, you can draw, you can find out the Miller indices, and at the same time you can think about the plane. Now you want to think the questions in reverse wise. That means if the Miller indices are given, you need to find out what is the intercept length. From that you need to draw the plane. So let's look at some of those questions first. Here they have given you a particular Miller indices of a plane. Now you want to find out what is the intercept length, or what are the intercept lengths. So here also you can think about the previous steps, but the backward. So from this you can take the Miller indices, Miller indices 1, 2 and 2. Now we know Miller indices are directly proportional to the reciprocal. So the reciprocal is that also 1, 2 and 2. And I already defined Miller indices are reciprocal to the fractional intercept. So the fractional intercept is 1 over 1, 1 over 2 and here also 1 over 2. Now we know fractional intercept equals intercept length over axial length. Find out the fractional intercept. Here we have given, so from that we can write 1 equals intercept length x over axial length a. Then for this one we can write half equals y over b. And here also half equals z over c. From that you can write the value is here a, that means the intercept length, that is the correct intercept length. Here this is a, here b over 2 and that is c over 2. So these are the things you need to find out by using the Miller indices, those intercept length. According to this one the value is a, for the next one it is b over 2 and for the last one it is c over 2. Now we want to draw this particular plane. We already find out a, b over 2 and c over 2 is the intercept plane. Now we want to draw it here. So x is here a and the y it is b over 2. That means this length b over 2. And the z-axis it is c over 2. That means this one c over 2. So now your plane is like this. Now your plane is like this. So this is the plane having Miller indices 1, 2, 2 or the HKL values 1, 2, 2. So likewise you can think about the if the Miller indices are given, you can write down the particular planes. Likewise, if you think about 1, 0, 0 plane, then 1, 1, 0 plane, then 1, 1, 1 plane. So these things are most frequently given in the exam, so you need to know, so you need to memorize, you need to study these planes very much. So here if the cubic crystal is like this, this will be your 1, 0, 0 plane. And for the next plane, for the next Miller indices, 1, 1, 0 plane will be this one. It will be this one. Then 1, 1, 1 plane, that is cut A, B and C. So the plane will be like this. Only the second one is going parallel to the z-axis. So that will be parallel to z-axis and only cuts A and B. So this is 1, 1, 0 and this is 1, 1, 1. These are the things I wanted to discuss with you today. So in the next session, we need to focus on the lattice points in cubic crystals, that means in face-centered, body-centered and simple cubic systems, and also how to find out the planar density. So those things you can see in my upcoming video. So that's all for today. So thanks for watching.